Hey folks, I'm Jimmy Ray Purser. Time to join me in the lab. Hey folks, thanks for joining me in the lab. Today we're going to talk about control plane policing. Now, control plane policing is really a great way to protect your control plane, the network. Let me go ahead and bring up a diagram here and show you exactly what it is that we're doing, because control plane policing can get a little confusing if you don't really understand what it is we're actually policing out there. If we take a standard router or switch type architecture, and I'm going to configure this on the router, but the architecture is going to be pretty much the same. This is my CPU, and I've got an ASIC or TCAM down here that's processing packets. I've got my port sitting on here, so this is, let's say, interface gigabit 0. When my packets are coming through, what I really want to do is I want to fast path these packets through the ASIC and out to their final destination here, this other interface. That's gigabit interface number 2. This is the path that I really want all these packets to flow in, right? No big surprise. If I've got to leave this control path and have the CPU actually manhandle and process something, this is what we call a punt. And punt means I'm literally, I can't process it inside the ASIC, so I've got to punt this out, and sometimes people refer to this as the punt path. So the CPU will actually do its processing, its calculations via the punt, and then it will send the information down to the port that it needs. And you can see this gets a little time consuming. This is when we're actually doing what's called software switching, that type of stuff. And we want to really protect this punt path more than anything out there, and that's where control plane policing really comes in. It's a 4-step process. It uses the MQC configuration methodology. So, if you're already very familiar with MQC, then this will be a real piece of cake to set up. You've just got one additional step, and that's assigning the service policy to the actual control plane. But in essence, look at it like this. I'm taking my control plane, my punt path, my CPU, and really turning it into another interface. An interface that I can actually protect on this network. So let me show you how we set this up. Let me exit out of here. Now we don't want to keep that. Setting it up is, there's a couple caveats in setting this up. So I'm going to try and go through these as you configured it, or as we're configuring this up. The first thing we want to do is set up our class map. Right, MQC type of format that we're very similar with. We set up our class map and we give it a name, so we'll just say this is CPP1. You can notice here that we just changed down to the CMAP prompt. On our CMAP prompt, we're going to actually tell it what access group or access list we want it to match. So I'm going to say I want to match access group 101. This is an access control list that I pre-configured. I'm reusing information. That's the point of using a great methodology of configuration like MQC, is I'm reusing elements that I've already configured. I'm not going to have to go back and reinvent the wheel. Stuff I want to protect my infrastructure from, I can go ahead and reuse those modules and get it to go right. Just like we're writing code, we want to reuse as many modules as we possibly can. Okay, so now we'll back out of this, and our next step that we want to do is configure up our policy map. So policy-map. This is going to set up our services policy for us. We'll call that PMAP1. And now you can see that here. We changed down to the PMAP prompt. Let's go ahead and plug that in. All we're doing now is basically we are going to align this with this policy map, so we can get a little more granular. The whole point of this is getting more detailed and more detailed and more detailed and more detailed. So we're going to go ahead and plug that thing in here. We'll do class. Let me go ahead and do a tab to completion here. Our class default is the that's kind of the gotcha. That's not the gotcha, but it's the part of an MQC processing methodology that if it doesn't match anything, it goes into class default. You really want to minimize what you're putting in class default, because that's just like an implicit deny on access control list. If it doesn't match anything, it will always match class default. So we want to go ahead and customize and plug it. Do not use class default for control plane policing. And another thing too, just to kind of keep in mind, if you're doing access control list, you're setting this up, I've seen a little weird behavior when you have log commands on those inside of control plane policing. So I very strongly recommend, as a best practice, to not use log commands unless you've tested them first out. So let's go ahead and finish configuring this up. I can sit there and tell stories all day. So CPP1, that's our class. You can see that now we went to PMAP class. We're just sidestepping it down. And now we want to tell it what we want to do in the class. Here's where we're getting granular. Here's where we set up our policing commands. Got to spell them right, though. So inside of policing, this is where we're setting out what our bit error rate is, whatever the case may be that we're wanting to monitor. We're just using this as an example, so we'll use 8,000. Let's just use 80,000. 8,005. There we go. We'll plug this information in. Our next thing is what we want to burst that out at. So we'll just say, well, I really don't want to burst it out. We'll do a conform. So conform action is that once we hit this number, what is the action that we want to take? Here's our actions. We can drop it. We can, set all these. I don't need to be reading all these. You guys can see all these things. When you're very first setting this up, I very strongly recommend when you're putting this in your lab, you're trying to test this, set your first action as transmit so that you can look back in your logs and you can see what's hitting and what's not. It's kind of like when we're building out an infrastructure access control list where we're kind of testing everything first before we get solid on it. A control plane policing policy will always change and evolve with time. So don't put it on and think that, okay, it's on, now it's done, and we don't have to mess it again. You really do have to look at your network and always kind of change it. It needs to be dynamic in your network, so it is always giving you the maximum benefit on your network. So on this one, we're just going to put transmit in here. And then on the at the transmit command, we say if it exceeds that action, what are we going to do? And again, you're going to have the same options again. We'll just say drop on this one. And then if we have a violate, violate's an option. I'm not going to put that in there this time, but certainly you can. And that's it. We've set up our MQC piece of this. Now, steps 3 and 4 are the control plane policing policy stuff. These are the easy steps. The big stuff is right up here. We just did it. So if you got this far, hey, man, you're almost done. This is a piece of cake. So now we go from here. Let's exit out. Exit out again. I probably should just do an N. And then there we go. Config T. Now we're going to go ahead and get right into the control plane. Control plane. Enter now. You can see our prompt change to CP. And here's where we're going to put on our service policy that we just defined right up here, which was our PMAP 1. So we'll do service, policy, PMAP. Got to spell it right. PMAP 1. And we're going to say that we want this to be inbound. Any other options? Oops, that's not right. Service policy. There we go. In. And then the name of it, PMAP 1. Ta-da, there we go, it's done. Really a piece of cake, and this is a great feature. I really like it. I don't deploy any networks at all, no matter what the size of my network, without putting control plane policing on. A lot of people get a little bit gun shy of it because of some of the parameters that are involved. You can figure in here, do it slow. You can see, man, this is a demo, and I made a few bumps along the way. That's just normal. The system is not going to crash and going to die on you or anything. Just go ahead and walk it through. Consider control plane policing a multi-step process that goes on forever, that you're always fine-tuning it and you're looking for how to adjust it and make it bigger and better every day. It will totally protect your network and your most valuable asset inside of the switch, which is your processor time. Hey, folks, thanks for joining me in the lab.